Have you ever struggled with cutting carbon steel or galvanized sheets? As the cutting settings of these two materials are similar, this lesson will take carbon steel as an example to show you how to cut these types of materials. To cut 2 mm or thicker carbon steel and galvanized sheets, use oxygen with a purity of 99.99% or higher as the shielding gas. Employing other gases may cause dross or incomplete cutting. As shown in the video, the gas supply requires an oxygen cylinder, a flow meter, and a proportional valve, and the gas tube should be connected to the main unit's shielding gas inlet. If you're using the 1200-watt xTool metal fab laser welder, set the gas pressure between 0.05 and 0.06 megapascals. Slight variations are acceptable. Here, we use a flow meter and a proportional valve to adjust the gas pressure to the required range. The proportional valve model is shown in the video. Alternatively, use a gas pressure regulator like the one in this video. Next, select a proper nozzle according to the table. For details about how to install a nozzle, click the upper right corner. Then, put the material in place. This video takes 5 mm carbon steel as an example. Use the fixtures on both sides to secure the material. Open xTool software and connect the device. Open a project file for cutting. For optimal cutting results, add a lead-in for carbon steel or galvanized sheets thicker than 2 mm. The lead-in ensures smooth and complete cutting of the contour and leaves the cutting defect outside the workpiece. The material thickness in this video is 5 mm and thus requires a lead-in. The following will show you how to add one. xTool software can automatically generate a lead-in. The lead-in length is usually 1 or 3 times the material thickness. To cut the interior part, add a lead-in inside to avoid workpiece damage. Alternatively, we can manually draw one. After adding the lead-in, set parameters for cutting. xTool software provides varied types of carbon steel as the processing material. Select one that matches your material grade and thickness. Then, select oxygen as the shielding gas and a 1 mm double-layer nozzle as the processing nozzle. Next, click Calibrate the capacitive sensor. Click a solid area on the canvas and wait until the calibration is done. Then, preview the precise cutting position using the framing or the close view function. The framing function is used in this video. Before processing, adjust the focus position, as the wrong focus position can lead to incomplete cutting or dross. Based on the software prompts, the welding head scale for our material should be adjusted to -2. The following shows the adjustment process. Finally, calibrate the optical path to adjust the red light position due to the added extension tube and changed focus. Always adjust the optical path last for optimal calibration. For details, click the upper right corner. After the adjustment, close the lid, click Start, and press the button on the device. The workpiece is very hot after cutting. Wear heat-resistant gloves before touching it. In addition, you're advised to bring a small hammer because a workpiece in an irregular shape may not fall off due to friction. In this case, use a hammer to knock it off. Pull out the base plate and pick up the workpiece. Look, this is the workpiece, a carbon steel wrench. The wrench is cut through in one pass, and its cutting surface is smooth without dross. Let's see if the wrench works. Here are some tips for better cutting results.